right, so in this video, we're going to go over the probability questions in the midterm study guide. So let's start with problem 32. You want to read it out? Oh, 22, yeah.
If we roll a six-sided die, what is the probability that we roll the following?
Okay, so we know that if we roll the die, we have these options: 1, 2, 3, 4, 5, and 6. All right, so let's start with the first one.
A is the number 4.
So the probability of getting the number 4. So I've got 6 options. Remember, with probability, you're always going to have the total at the bottom. So I have 6 options: 1, 2, 3, 4, 5, 6. I'll put that here. And then I have just 1, 4. So if I roll the die, there is a 1 out of 6 chance that I get a 4, and that's it. So 1 over 6. Let's go to the next one.
The next one is an even number.
So an even number, probability of getting an even number. Now I have 2, 4, and 6 for even numbers. So I have 3 of them. So it's 3 out of 6. And you can reduce this to 1 over 2. So now the exam is going to be multiple choice. So if it's 1 over 2, that's fine. If it's 3 over 6, but it's not going to have both of them.
Right.
All right. The next one.
A number less than 5.
So a number less than 5. Number less than 5. Remember, it says less than 5, not less than or equal to 5. So 5 is not part of it. So numbers less than 5, you're looking at 4, 3, 2, and 1. So there are 4 options. So 4 out of 6, and that's it. The next one.
A number greater than 3.
Greater than 3. So here you are looking at 4, 5, and 6, because those are the numbers greater than 3. So 4, 5, and 6. So we have 3 out of 6, which is 1 over 2. And that's it. Okay. The next one.
Suppose we have 2 events that are independent of one another. What does this tell us about how we compute probability of A and B?
Okay. So for independent events, and these are in the slides too, the PowerPoint slides, to find probability of A and B. Remember, A and B are independent. So to find probability that A and B are happening, we're going to say that you multiply, this is the rule, the probability that event A is happening times the probability that event B is happening. This is the rule for independent events. So you go to the problem, what is the probability that A happens?
This is in the example number 24.
Yeah.
It says if events A and B are independent of one another, probability of A is equal to 0.2. And then probability of B is equal to 0.3.
Exactly. So you multiply them, and that's it. Multiply them. And this should give you 0.06.
Yeah.
Okay. And this always works for independent events. It's the rule. It's the rule.
Okay. So then number 25 is if events A and B are independent of one another, P of A equals 0.5 and P of B equals 0.8. What is P of A straight sign B close?
Yeah,
that
I
one.
like the way you said it. A condition. It's a condition.
Oh, condition B.
Yeah.
And that one confuses me.
So the probability that A happens given that B happens.
Okay.
That's what it means. So let's talk about that one too. So that is called conditional probability.
This is conditional. conditional.
Yep.
Conditional.
So in conditional probability, the rule says that, and this is a rule, it's always going to work. Now, look at the condition. This time here, given B. Now, this part here, given B, the probability of this will make the probability of B to be the denominator. So I'm going to put that here, probability of B at the bottom. And then the top is going to be probability of A and B, like that. Again, this is a rule. This is a rule. Okay. Again, the reason why I put B, the probability of B at the bottom, is that the rule says whatever is the condition, given that, put it at the bottom, and then A and B. So this really works fine when A and B are independent, because if A and B are independent, then this is what we just looked at. Probability of A and B is probability of A times probability of B. So for independence event, this is going to be equal to probability of A times probability of B divided by probability of B. And that is the same thing for P, A condition. And then you solve that. So let's look at the numbers. Yeah, what is probability of A? What is probability of B?
Probability of A is 0.5 and probability of B is 0.8.
Okay. Times 0.8 divided by 0.8. Then you put that in the calculator.
0.5.
Yep, exactly. Because
it just cancels out.
Yep, it cancels out. Yeah, I was just waiting for you to.
You could tell I didn't look at the board, right? I'm just moving.
Exactly.
0.5. I'm glad we went over that because that had me stumped in the homework too.
Oh, okay.
Because I didn't.
For me, it
wasn't clicking. I went to the textbook.
Oh, okay.
Yeah.
Yeah, I mean, these formulas are in the textbook, though.
Yeah, but the thing was, too, they were interchanging the B and A, so it didn't click for me. Yeah, and now it clicked.
Yes,
oh, yeah.
That's true. The A and B could change. Probability that B happens, given that A happens. The rule is that because the A is here, you put it at the bottom.
Yeah, and that's where I was messing up with the homework. Okay. But the P of A and B stays the same.
Yep. Yep.
For the numerator. Okay.
All right.
All right. Number 26 or?
Yep.
All right. 25% of people in the U.S. have type B positive blood. If we randomly sample 2 unrelated people in the U.S., answer the following.
Okay. What number is it?
26.
You're right, 26. Yeah. So 25% of people in the U.S. have type what? B plus blood?
Yep, B positive.
So
yep, B
I
plus.
would say probability for B plus blood is 25%. So if I meet somebody randomly on the street and I ask the person about the blood type, in my mind, I know that there is a 25% chance that this person would have type B plus blood type. Now, the question says, what about if you randomly talk to 2 unrelated people? 2 unrelated people. Answer the following questions. All right, let's start with the first one.
What is the probability a single individual has type B plus blood?
Okay, that's B plus blood. So I meet somebody on the street. What is the probability that this person has a B plus blood type? What is it going to be?
25%.
Exactly, 0.25. So that was the last one. Okay.
And then B says, what is the probability that a single individual does not have type B plus blood?
Exactly. So the probability, that's somebody else. The probability that the individual does not have B plus. Now, because these 2 are opposite, we say that this is a complement of that. It's the opposite of that. So this is going to be 1 minus 0.25 or 25%, which is 75%. Which is
This is a
75%.
good one. All right, so C says, what is the probability both people we survey have type B plus blood?
Okay, so now we are looking at both people have type B plus blood. So here, remember, these two people are unrelated. Now, the probability that the first person has B plus blood and the probability that the second person has B plus blood are independent. The probability, it doesn't affect the other, and that's independent events. So we're going to say the probability that first individual has B plus blood and second individual has B plus blood. Then you go back to the rules of probability, independent events. It says multiply probability that the first person has B plus times the probability that the second person has B plus blood. And both of these are 25% for the first person. Second person is also 25%. And that's it. You multiply that.
So that comes out to 0.0625.
That's it.
And then for this one, my question would be, this will have the full decimal values in there, right? So it'll be 0.0625.
Unless
or
the question says
is rounded to the two near decimals or something. Okay.
All right. The other one, the next question.
Oh, there's a D.
Yeah.
D is, what is the probability neither of the people have type B positive blood?
So no B plus and no B plus. So here you're going to go back to what we did here, the complement. Okay, the complement. So it's 0.75 times, because they are independent, you still multiply them times 0.75. That should give us what?
0.5625.
Yep. And that's it.
Okay.
Okay. So this is where we're going to end this video. I'll see you in the next video.